Shivam Rajput back again with a new video on our video series of CSI and HRF or Sciences. So in this video, I am going to talk about CloudBrust and its related uh, concepts. Okay, now this is very important topic as far as CSIR is concerned. In last 7 years, we have 16 plus questions directly or indirectly from this CloudBrust. So be there with me till the end of this video. Okay, and at last, I will discuss why there are more cloudbursts, especially in Uttarakhand region. Okay, so these are my source papers from where I got some pictures, some graphs, some plots. Okay. So let's see first how basically cloud forms. Okay, now during daytime, what happened? Because of sun heating, the water molecules from the water sources like oceans, rivers, it get detached, it turns into gas, and we know that gas is lighter than the nearby air, so it is also warmed up, so it is less denser, no? So it will simply move up. As it moves up, slowly temperature falls down, and there is a place where it finally condenses. That place at some height is called latent heat of uh, zone of condensation. That zone is called zone of condensation or level of condensation. Okay, beyond that level, it it condenses. Okay, now for condensation, what we need a cloud condensation nuclei, that is called ccn. Okay, so on one ccn, around 100 millions of water gaseous molecules finally condense to form a raindrop. Okay, initially it forms into a cloud when the weight of a cloud is sufficient to counter buoyancy, which is basically acting in the upward direction. In that case, we have a rainfall. If this rainfall is occurring in a high mountainous area, it turns into snowfall. Okay, so this is all about particular concept. So you can see here the animation, you can read the subtitles also. So here we have convection heating. Now because of this convection heating, there is a formation of clouds. In each cloud we have million trillions of ccn, cloud condensation nuclei, on which condensation occurs, and through condensation it becomes heavy enough to form a ice crystal, and by combination of these ice crystals it turns into a cloud. And you can literally see that one average side this rain cloud is having a weight of 100 elephants. Okay, 100 elephants. Now the question is, see, this is 100 elephant, right? And still it is floating. Why the cloud is floating? Answer is, there are two answers actually. The first thing is buoyancy. Buoyancy is basically whenever you put any object in a fluid, whether fluid is liquid or a gas, that object feels an upward force, and that upward force is considered as buoyant force. Here the buoyant force is basically due to vertical updraft winds, and vertical updraft winds is basically due to convection, due to convergence of air, due to frontal lifting, due to, you can say, orographic lifting. So these are the four conditions under which we get some buoyancy and an upward force. But after some point of time, if there is no vertical lifting, suppose there is no orography in that region, there is no convergence of air at that region, if there is no heating at all, if there is no fronts, in that case, that cloud becomes sufficiently heavy to counter this buoyancy. So now gravity will act. So now gravity will be greater than the buoyancy. In that case, we have finally rainfall. But there is also sometimes when cloud simply flows without downfall. Still, देखो, suppose there is a area where these all four forces is not acting. Okay, still there is no rainfall. Cloud is there, but there is no rainfall. You can see literally sometime there is an anticyclonic condition with some clouds. There is no rainfall at all. Now what is the reason behind it? Why those clouds are like simply floating in the sky instead of like falling down, instead of having more gravity than buoyancy? The reason is condensation, latent heat of condensation. Okay, now for that you should know this basic concept. So during evaporation of sweat from our body, we feel cold, right? We feel cold. Why? There is a this cold effect on our body, cooling effect on our body. It's all because of here we have latent heat of evaporation. So during latent heat of evaporation, water molecule carries heat with it. In this case, here there is a latent heat of condensation. So the air close to this glass is having some water vapor in a gaseous state. When it comes in a contact with a cold surface, it forms dew. And during dew formation, this water will release heat. In this way, water will turn into a dew, but the nearby region is now warmed up. So simply during condensation in a cloud, it will release latent heat of condensation, which acts as a hot air balloon. So in a case of hot air balloon, the air which is inside this balloon is less denser than nearby air, and that's why the balloon is lifting. That's why it is floating, right? In the same way, cloud is having lots of latent heat of condensation. Think of it, it is equal to 100 weight of elephants. So how much latent heat of condensation is present, and that's the reason why it is warming inside the cloud. And that's the reason why the height at which this cloud is present is basically less denser than the surrounding. It is less denser than the surrounding, and that's why it is lifting. It is there at that reason. Okay, now according to IMD, Indian Meteorological Department, the definition of cloudburst is basically a precipitation over a geographical region of 20 to 30 kilometers square. Now let's see what a cloudburst is. Here we can see a cloudburst activity going on, right? A gigantic cumulonimbus cloud is there, and in the center of this cumulonimbus cloud we have cloudburst activity. So let's see what a cloudburst is. According to IMD, a precipitation rate equal to or more than 1000 millimeters per hour over a geographical regions of 20 to 30 kilometers square area is considered as a cloudburst activity. In simple words, we can say that a cloudburst is basically an extreme amount of precipitation in short period of time. Okay, और कितना होना चाहिए रेट? More than 100 millimeter per hour. Okay, in some places it is also considered as skyfall. Okay, skyfall, basically the entire sky is falling. Right, it's like you are having a balloon filled with water, and all of a sudden you simply blast that balloon. So all the water inside the balloon will fall down, no? In a small amount of time. That is called cloudburst. Okay, so this phenomena is basically occurred with hails, thunder. It will having effect. It will also create flood conditions. Okay, it can occur in mountain region, desert area, even interior part of the continental land masses. That is very common. Okay, so and yeah, if you talk about Himalayas, these cloudburst activity is more common in the southern rim of Indian Himalayas. Southern rim, मतलब Indian side. Okay, basically in Uttarakhand region, Himachal Pradesh region, where things are where mountains are basically having a bowl-shaped structure. Okay, so yeah, and even in Himalayas it is more disastrous. The reason is in the Himalayan orogeny there is very steep inclined surfaces that helps this cloudburst to lead flash floods, landslide, mudslides, and all. Okay, so this is basically a frequency of cloudburst in India. We can see it is maximum in the Uttarakhand region. Okay, and then Himachal Pradesh and Kashmir, basically in mountain regions. So these are the mountain region, right? Himalayan regions. Uttarakhand, Himachal Pradesh, Kashmir, all belongs to Himalayas, right? So here we have maximum frequency. Even Delhi is close to the plains, right? And yeah, so these regions are having very least amount of this cloudburst activity. ऐसा नहीं है कि नहीं होता. In the mountain region as well as in the plains we have, okay, close to the ocean coastal region we also have some cloudburst activity. For example, in Mumbai, we had already this cloudburst activity close to Dadar. Okay, so yeah, it's very common. In 2010, we had such activities, but the mechanism is different. For plains, it is different. For mountain region, it is different. In plains, it is basically a frontal cloud burst. Okay, so because of the front formation, there we have cloud burst. Here in the mountain, the mechanism is little bit difficult. So let's see. Okay, now why does Uttarakhand is highly affected? So there are various reasons. Okay, first of all, let's see how monsoon works. Okay, we know that there are two branches of monsoon. One branch is called Arabian Sea branch, which basically enters here, and it is having activity all across the Western Ghats, because in the this side, in the leeward side of Western Ghats, there is a drought like conditions. In the windward side of Western Ghats, we have heavy rainfall. Okay, here we have Aravallis from Delhi to Gujarat. Aravallis is like this. So some monsoonal winds moves parallel to Aravallis, and in this way it will enter to this Kashmir, Himachal and Uttarakhand region. Okay, parallel to Aravallis. Okay, in this way there is no precipitation in the Rajasthan area. Okay, if this Aravallis is like this, okay, 90-degree or at some angle to incoming Arabian Sea arm of monsoon, it will have precipitation, and it will have some forest also. But since it is parallel, exactly parallel to this thing, no, upcoming this monsoonal winds, that's the reason why there is no rainfall in this area, and that's why it is facing desertic conditions. Okay, we know that during summer monsoon, these cloudburst activity, no, it is more common in onset of monsoon, close to onset of monsoon. Suppose uh, onset of monsoon is say 1 June at Uttarakhand, so it will occur some 5 days, 10 days, 15 days before onset. Okay, let's see why. What is the reason? Here we know that in summers there is a formation of low pressure zone at Tibet. Why there is a low pressure zone? It's all because of ITCZ presence, right? ITCZ is present, and yeah. Here we know that there is a point called Pamir Knot, which simply divide STJ called subtropical jet streams into two arms. One arm move this way, north of Himalayas. One arm move south of Himalayas. Now, for monsoon, what we need? For monsoon, we need shifting of this southern arm of STJ to north. Once this southern arm of STJ shifts to north, we have pretty good rainfall. If again it comes back, in that case we have monsoon break in India. Okay, so for a good rainfall in India, I'm talking about monsoonal rainfall. What we need is shifting of this southern arm to north of this Himalayas. Right now, in this condition, we have this STJ over uh, this Ladakh region, Kashmir region, Himachal region, and basically this Tibet region, right? Now this is conducive. This STJ is important for the formation of cloudburst. Now let's see how. I will come to that photo later. Okay. Now in this photo we can also see that some of the monsoonal water mass, monsoonal airflow is moving also from Bay of Bengal region. Now this Bay of Bengal region is having more moisture. The reason is the air which is coming on into the Indian continent is traveling more over the ocean. See, in a case of Arabian Sea, it is traveling less distance, no, over the ocean. But over here, it is covering more distance. So more distance, matlab, it will now become more saturated. And in this way, in India, the most of rainfall occurs because of this, right? Because of this, because of this Bay of Bengal arm. Okay. Now some of the arm also moves all the way to the Uttarakhand region. We can see in next photo. Second thing, if STJ is over Uttarakhand, a Himachal Pradesh region, that means there is some moisture all the way coming from this Mediterranean Sea region, right? That is also known as Western disturbance. So some moisture is coming from this region, but relatively the amount is less. Okay, so this STJ is relatively dry as compared to this Arabian Sea branch and this branch, Bay of Bengal branch. Okay, I will come to this photo later. Now, here we have a low level of moist flow. This is Arabian Sea branch and this is Bay of Bengal branch. Both are moving all the way to the Uttarakhand region. We have some dry airs which is coming from the deserts. Okay, deserts of Middle East, Pakistan, Iraq, Iran, all these things. We have northwesterly winds. This is what? This is basically your westerly STJ. Okay, it is dry. It is moving at a higher heights. It is having no moisture at all, or relatively less moisture, you can say. And okay, so we have this kind of circulation. Okay, now this moist flow is actually on the surface. Okay, so as it moves towards this region, these mountain regions, it will basically act as a funnel structure. Okay, so there is a gateway to move inside, but there is no exit. Okay, door. So there is a door which, so basically you can say that there is a one side entrance, there is no exit. So moisture is basically building up over here. Okay, in simple words we can say that this cloud burst happens when the saturated clouds are unable to produce rain because there was a upward movement of very warm current of air. So this is very warm current of air, and we know that warm current of air is having lots of moisture in it, right? So it is unable to exit out. So what happens then? In that case, it will simply build up in that region only. So it will simply form a cloud in this region only because there is no exit. No, it's a funnel like structure. There is an entrance only. Okay, so this instead of dropping down, the entire moisture is carried upward by this air current. Now new drops are formed and the existing raindrops gain the size over a period of time. Okay, so after some point of time, the raindrops become too heavy for the cloud to hold on. Okay, and at this point they drop down together in a quick flash. So it's like a skyfall activity all of a sudden. It is not essential that the cloud burst occurs only when the cloud clashes with a solid body like mountains. So it's not necessary. Sometimes these dry northwesterly winds pick moisture from this low level circulation, and it simply collide this moisture with the mountains. In that case, we have cloudburst activity. So it will help as a like triggering mechanism. Okay, it will trigger it, but it's not necessary. Okay, it's not necessary. So like one such cloudburst in Himalayan region occurred when the monsoon winds are rising along the slope of Himalayas. Now think of it. Here we have mountain region, right? This moist rich air is coming all the way from Arabian and Bay of Bengal region. Okay. Now on the surface, it is not a cloud. It is in the form of a warm air, simply a warm air. But as it hits the slopes of Himalayas, it will simply lifts, right, through orographic lifting. And as it lifts, there is a point at some height when it reaches the level of condensation, and beyond that line, beyond that altitude, the entire moisture will turn into what? Cloud. Okay, and since there is only one gate, so there is a continuous addition. Okay, it will simply pile up the cloud over there, and if it will become cumulonimbus cloud, in that case it get captured with this northwesterly winds, and then it collide because it is a fast moving wind, no, so it will suck all the moisture and collide here matlab in the outer parts also. Okay, so in this way we have this thing, formation of cloud burst. So initially what happens, this water laden winds will rise because of this orographic lifting, because of convective lifting both. Then this water laden winds absorb more and more moisture. With time it becomes heavier and heavier. and there was a point when there is no vertical upliftment. Vertical upliftment कैसे होता है? Because of this convergence, because of this convectional heat, because of orographic lifting, because of frontal formation. Suppose at some point there is no PGF, so in that case these two arms will become weak, no. And if there is no intake from Arabian Sea and Bay of Bengal branch, then the cloud over here becomes sufficiently heavy to fall it down, and in that case we finally have rainfall, cloudburst. Okay, and see, in this case the vertical shear is also important. So this dry northwesterly winds is basically providing vertical shear, and that's the reason why it is creating space to further build up of clouds. यहाँ से इस clouds को हटा के दूर लेके जा रहा है, right? So there is now space to further addition. Okay, so it will advances the formation of cumulonimbus clouds. Okay, in this photo we can see the same thing. So here the moisture is coming from the Arabian Sea region, this moisture is coming from this Bay of Bengal region, and there is a orographic lifting, there is a convective lifting. As the lifting occurs, there is a formation of clouds, and the upper atmosphere we have divergence of winds. And why there is a divergence? It's all because of STJ, already discussed in previous video. Have a look. Monsoonal trough line is over India, that means already this ITCZ is over India, right? So yeah, here also we can see the same thing. Moist from the Bay of Bengal, Arabian Sea and Bay of Bengal region. Low pressure zones are formed over here and clouds are getting developed. Now this is the one reason. Another reason is this one, Tehri Dam. Okay, now let's see in real time how Tehri Dam looks like. Okay, Tehri Dam. Let's move to the Tehri Dam. Okay, it's the highest, tallest dam, you can say, tallest dam in India. Okay, so let's see the 3D view. Okay, now this Tehri Dam is over two rivers, that is Bhil Ganga and Bhagirathi. So this is the downstream side you can see. Let me pause. So this is the spillway through which water goes out, and this is the reservoir. This side we have reservoir. Yeah, this is Bhagirathi river, and from one side we have Bhil-Ganga. Both meets, and finally it forms a huge storage of reservoir. So Bhil-Ganga is coming from this side and Bhagirathi is coming from this side. Let me pause and now let me show you. Look. So you can see this is Bhagirathi region and this is Bhil-Ganga. Both meets over here and finally form a huge reservoir. Now here it looks very small, but in reality, let me show you the facts. Okay, so it is an embankment type of dam. I will make a separate video for dam also. Okay, here we can see that the height is 260 meter above the sea level. Matlab the height of reservoir, the height of that dam spillway, it is about 260 meters. Think of it. यानी जो वाटर वहाँ डिपोजिट हुआ होगा that is close to this much of height. Okay, we know that these mountain regions are V-shaped regions, right? And if you increase the water level in that region, what happens? The surface area will increase, no? Surface area of water will increase. So this is the length of dam, and this is the height of dam. And in the backside of dam, the reservoir is almost equal to 260. एकदम 260 नहीं होगा. In monsoon time it will become 250, 240. Okay, but it is very huge amount of water. Think of it. The spillway capacity is this much. Yani per second this dam will release this much amount of water. Now think of it. It's very huge. The total capacity of reservoir is, see, 4 kilometer cube of water. It's total capacity, and the surface area is 52 kilometer square. Now this is very important. Surface area 52 kilometer square. See, initially the dam looks like this. The river looks like this. It is very shallow. We have vegetation all across. Now think of it, suppose we make a dam over here. Now the entire this much region, 260 meter, think of it, 260 meter. So the entire forest area, the entire this region will filled with water, no, because we are basically blocking the water. So what happened? The entire this thing, the ecosystem will submerge under the water. 260 meters. Right now it is say 5 meters. It is having width of 5 meters. Okay. After blocking by dam, the height becomes 260 meter. Right now it is 1 meter, let's say. It becomes 260 meter. तो इसी के कारण देख रहे हो ना, 52 किलोमीटर स्क्वायर एरिया में this entire this is dam here. Okay, this is the water body. So the water body over here is now very enormous. Bhilganga is coming this way and Bhagirathi is coming this way, already shown in this video. Tehri dam. So the water body is very huge now. Okay, once that is formed, suppose dam is formed now, अब क्या होता है? I told you that here the entire vegetation after formation of dam will submerge in the water. Now this vegetation are way here, the forests are very dense. Okay, so these are having carbon compounds, right? So once you submerge any forest inside of water, what happened? This the entire forest will start decomposing, right? Decomposition will occur because this is organic matter, no? And once organic matter decomposes, what happened to that water body? Because most of the time this reservoir is closed, the spillway is closed most of the time. Okay, so the entire water body over here is basically having condition of hypoxia. Why there is a hypoxia? Because these organic matters are decomposed year by year. It will take a huge time. It's not one day process. Okay, so it will take like 20-30 years to decompose these forests. And during decomposition, bacteria uses all the oxygen present in that water. Okay, so it will affect indirectly fishes because they want oxygen for their respiration. And since organic matter is present, all the oxygen is used by bacteria to decompose. Okay, for decomposition we need oxygen. For respiration of that bacteria we again need oxygen. So there is already what happened? There is a already absence of oxygen in that water. In this way, it will affect the ecosystem over there. Okay. Now, whenever this organic matter decomposes, it will release methane and CO2. Organic matter will release methane, and these bacteria, since they are there is a respiration going on, so it will release CO2. Now we know that these Himalayas are very sensitive in nature, right? They are very sensitive, and you are producing carbon dioxide and methane, these kind of gases. These are greenhouse gas, right? Methane is 24 times more greenhouse than the CO2. It will absorb 24 times more infrared radiation than CO2. So you are basically that's the reason why no there is a melting of glaciers in the Himalayas. That's the reason why the decadal temperature rise in Himalayan region is higher than the global rate of rising temperature. Okay, it's very high. Several climate changes studies over the Himalayas reported that there is a consistent warming in the present climate with a warming rate of 0. 0.4 degrees Celsius. It's very huge. So it's all because of the submergence of organic matter. Now, how it is related to formation of cloudburst? Let's see. Okay. Yeah. Now at this height, the incoming solar radiation having more intensity, right? Because it is close to the sun, right? Comparative to plains, comparative to mean sea level. This is close. It is above mean sea level, right? So intensity will be more. We also know that since this water is coming from melting of glaciers, that means it is no doubt of fresh water, and fresh water is having low specific heat. That means it requires less amount of heat to evaporate as compared to saline water. Okay, So whatever moisture is coming all the way from Arabian Sea and Bay of Bengal, it will also that moisture is getting saturated from evaporation of this region. Okay, suppose air is coming from Arabian Sea, it is having say 40% of relative humidity. Okay, but once it reaches over here, it meets this surface 52 kilometer square area of fresh water. Okay, it is having less specific heat, so it will simply evaporate this water also. Convective heating also create evaporation, not only that dry air mass but also the convective heating, and in this way it will super saturate the air mass over there, super saturate karega, and finally it will form a clouds, cumulonimbus clouds. So it's all because of this enormous surface area. Initially it is something like that, it is something like that. So here evaporation is less, no, now you fill all the valley by this much of height through water, इतना भर दिए तो क्या होगा, more and more evaporation will occur. And that's the reason why after the formation of this dam the frequency is more. This is the reason. Second reason is what, greenhouse gases is basically coming out of this reservoir region, and that is increasing the rate of melting. Okay, this is greenhouse gas, no, methane, CO2, it increases the rate of melting. Okay, and this rate of melting further enhances more surface area, more and more surface area, even in this region also. See, right now the 52 kilometer square area is basically close to the dam, but as you move away you can literally see at some height you can see some ice snow, but now glaciers are receding, so this water area is now exposed. Even in this region you can see this is whole water. Few decades back you get glaciers in this region, but right now it's whole water, and we know albedo of water is very less, 5% only. For glacier it is 95%. That means 95% of incoming radiation is simply reflected, but now because of this greenhouse gases everything is turns into the water, and now reflection is less. Are you getting my point? So in this way it is further enhancing, it's like a positive feedback effect, positive feedback. So because of melting, now there is more formation of cloudburst activities because of increase in surface area. Okay, so I hope you get my point. So already discussed. Now currently we are having strong rainfall, heavy rainfall in this Uttarakhand region, Chamoli districts, this Khirganga region in Himachal Pradesh. It is not a cloudburst. Here we can see, according to uh, this Dr. Manish, okay, according to him, it's not a cloudburst activity. And also, according to IMD, it's not a cloudburst activity. It's basically a convective rainfall. Convective rainfall में क्या होता है? We have heating, localized heating. That localized heating cause warming of air mass. Since warm air mass is less dense, it will move up, and by continuous process, it will form a cumulonimbus cloud, and finally, it will simply cause cloudburst. Okay, so you can take a screenshot of this. So right now it's not a cloudburst activity, it's a convective rainfall. Okay, now effect of cloudburst. So the most disastrous effect of cloudburst is flash floods. So cloudbursts are also responsible for flash flood creation. You can see in Kedarnath region, it already happened. We have seed floods, landslide, mud flows, land caving. All these things are common. Okay. So is it possible to forecast? So the answer is no, not 100%. Prediction and the location as well as amplitude, magnitude of these cloud bursts are remain a challenge. Okay, it needs more research. Basically, these things are very localized now. It occurs in a small area, and that's the reason why there is difficult to find cloudburst. And basically, in that terrain, Himalayan terrain. Okay, uh, so yeah, this is all about mountain cloudburst, and in the plains, it's the concept is same. Only the mechanism is there we have frontal lifting. So there is a frontal lifting of warm air mass. It will turn into cumulonimbus clouds. Once it becomes sufficient heavy, it bypasses buoyancy force, gravity force will occur over there, and there is a all of sudden rainfall in that region. You can see there is a intense rainfall in a small amount of time, and in this way there is a cloud burst in plains, okay, like Mumbai and all. Okay, so that's it for the today. I hope you like the video. By the way, this is my website. We have covered all the topics of CSIR, basically from atmospheric sciences, oceanography, planetary sciences with hand written notes, 4,000 plus questions, solved numericals, everything is there. So have a look. You really like it. Okay. Thank you very much for listening. और अगर तुम अभी तक वीडियो देख रहे हो दैट मीन्स यू आर रियली इंटरेस्टेड यू रियली वांट टू क्रैक CSIR. So best of luck from my side, and please like, comment, share, subscribe my channel. Thank you very much.